All right, so I posted an announcement with like 4 of the really top things that I saw in the muddiest points. So if you had a very sort of like individual level question, I tried to respond to you directly in the muddiest points, but then rather than duplicating responses throughout the muddiest points, I just posted kind of like the top ones. And a lot of them are, I think, we're going to at least handle a little bit here, where today's lecture is all about these kind of actually doing some examples, the numerical examples, so that we're kind of on top of like, how do you use the demand curve? How do you use the inverse demand and so on? And so that's what we're going to be doing today. But as I kind of mentioned before, attendance for today's lecture is kind of handled a little differently. So there's not going to be attendance exercises built into the live lecture. This lecture was originally built to be something you could do at home on your own. And then so like if you click on lecture B5A on Canvas, you'll see that it's like a Canvas quiz. And that is actually the attendance assignment for the day. And so if you go into that, you can go into it as many times as you like. And they basically cut things. There's like 6 10-minute videos, and you watch 10 minutes, and then you answer a couple of questions on Canvas that get auto-graded. And then you can take them again or whatever, but they're meant to just be like attendance questions. And so it is basically an asynchronous version of what we would normally do, so that you have an opportunity to kind of do more practice with this at your own pace. So if that more suits you, you can feel free to do that. To get attendance credit for today, you're going to have to take those questions anyway. You don't have to watch the videos. You can just do the questions, or you can look at the questions and then watch the videos if you need some clarification. But so that's how attendance is handled for today. With that in mind, if you got other places to be right now and you'd really rather not be here, you can feel free to pop off. It's not going to offend me. What I'm doing here is basically going to turn that asynchronous lecture into a synchronous lecture, where we'll go through a bunch of examples and give people an opportunity to ask questions here. I have spots that I've put in these lecture slides that tell you where the Canvas questions go. If we had more time, or if things are going really quickly, then I might say, oh, let's pop out into a breakout room, and you guys can maybe pop out into a breakout room, and then you guys can maybe work on these 2 Canvas questions together for a minute. But I don't know if we'll necessarily do that. I think it's probably going to be more driven by people asking, like, why did you plug in P there and not Q there, or so on and so forth. There's a question, when do we need to complete the lecture? I forget what due date I've put on that. It should be listed on Canvas. It's at least 24, you have at least 24 hours, and I'm guessing you have more than that, and I don't know for sure. Here's what I'll do. I will say that if it is not already at least this, I will make it this. You have until the next lecture to do today's lecture. And so Julie mentioned that I believe it's the 21st by 10 a.m., which would be a week, I think, right? The 21st, did I get that right? Today is the 15th or something. So yeah, it will be at least by Thursday, but potentially longer. So if it is already longer, I'm going to leave it at that and just look at the Canvas due date. But otherwise, you'll get at least until the start of the next lecture to do it. So again, if you don't want to be here, you don't have to be here. But for those that just want to hang out for this, for the normal 75 minutes, and then we can work on these problems together, you can ask questions, that's fine to do that too. So that's how things are laid out. So don't expect the typical attendance exercise, but do remember that even if you've attended the synchronous, to go onto Canvas sometime in at least the next 2 days, maybe longer, depending on what I set the original due date for, and go through and answer the couple of questions to get your attendance credit. But if you don't do it, it's really, really minor. It's 1 day's attendance credit, and there's a drop policy. So. All right, so these are the exercises. So before we get into the quantitative ones, then let's start practicing with the qualitative things. So the end of last lecture, I said, these are a couple of kind of quick thought exercises here. So we just had learned about this price elasticity of demand, and the PED is meant to represent how the quantity changes if the price changes. And so this formula that's up here is basically, if I were to turn on my pen, this is basically delta Q divided by Q over delta P divided by P. And so you can think of this as the fractional, that if you change the price by the fraction in the denominator, then this tells you the corresponding fraction of the quantity that would change. So a PED of 1 would mean that if I increase the price by 5%, then the quantity will decrease by 5%. And so an elastic PED is one where you get a large change in quantity for a small change in price that is very responsive to a change in price. An inelastic PED means that regardless of you changing the price a lot, the quantity purchased doesn't change that much. So without us even worrying about the formula too much, we can at least try to guess whether things are inelastic or elastic. And that's kind of the first things here. So here's one scenario. Let's say I have a lot of substitute goods available. In other words, you know, I really like this, you know, squishy ball as I lecture, but occasionally I could use this fidget cube. So the fidget cube is an alternative that I could purchase. So if my squishy ball pops and the white gunk that's in it, you know, goes everywhere, I can either go out and buy a new squishy ball, or I can go out and buy one of these guys. And so the question is, if somebody changes the price of the squishy ball and I have substitutes available, then how is that going to affect how many squishy balls I end up purchasing? So do I pay attention to the price of the squishy ball if I have other alternatives available? So what do you guys think? So how many people would say that, and we can maybe vote in the participant list. And so let's say there's, if you look at the bottom of your participant list, I think you should see, let's say a yes or a no. And so what I want you to do is vote yes if you think this would be an elastic good, and no if you think this would be an inelastic good, if it's a good with many substitutes available. So is the good elastic yes or inelastic no? And vote with the yes or no in your participant list. And then yes is, I think I said yes is elastic and no is inelastic. And elastic means PED less than 1, inelastic PED, I'm sorry, elastic means PED greater than 1, inelastic means PED less than 1. And I will wait for a couple of answers to come in here. So if the good has lots of substitutes available, is someone going to be very responsive to price? Yes, if they'll be responsive to price, it's elastic, or no, they will not be responsive to price. They'll ignore price and they'll keep buying the same amount. And here I'm seeing, if I look at the aggregate here, of the people who voted, I see 8 or 9. So someone looks like they're not sure. So I see 8 or 9 yeses and 2 nos. And so it looks like the yeses have it. Could somebody who answered yes tell me what their reasoning would be? Why would this be an elastic scenario? And that, by the way, is my answer too. So if that helps you. So somebody who guessed elastic, I'm saying that is what I would say is the right answer. Tell me why you think that's the right answer. Anybody? Okay, I see a comment in the chat. And I'm reading the comment right now. All right, so any other responses before I jump ahead? All right, so the comment in the chat says that if there's a substitute, then if the price raises, you'll be more inclined to buy the substitute, or at least some people will be more inclined to buy the substitute. And so the original one, the quantity demanded of the original one will go down. So this is an example where I would say it is elastic because you can buy a substitute. So if the price of the green ball goes up, I'm more likely to just buy more of the other thing, more of the fidget cube instead. And so as a consequence, then it is elastic because I am responsive to price. So, so we can think of it, let's try some other things. Well, what if instead I've got, you'd say, well, this green ball actually, I make a lot more money than it costs to buy a green ball. So really, how responsive am I going to be to the green ball's price if the price of the good is really, really small relative to my income? And so, so this is like the argument that, a little kid, like, walking through a toy store will say, Dad, or Mom, it's only $1. They'd say, certainly you can afford to buy me the $1 toy. And then the mom or dad might say, but it's not worth $1. So there's those sorts of questions. But so it's like the little kid is making the argument, but it's less than your income. It's significantly less than your income. You can afford it. And if it were $1.50 or 50 cents, would the argument change that much? So the question here is, if the good is cheap relative to your overall income, do you think the good is more likely to be inelastic or elastic? So maybe in the chat this time, how do people vote? Do you think this would be an inelastic or an elastic good if the good has a cheap price relative to your income? And I know there's at least 8 of you out there who were paying attention last time, so I'm gonna hopefully getting good 8 answers here. And you can, I guess you can also vote in the list or in the chat. So far, I have seen it looks like a flip. I'm seeing that between the chat and the participants list, we've got about 9 or 10 inelastics and 1 elastic. And my vote would also be for inelastic. And I'd say it's inelastic because an increase in the price is not going to change your likelihood to buy it. So if it's $1, if it's $1.50, if it's 50 cents, it's not like, if you make significantly more than that, then it is such a small fraction of your income, then your decision making is not going to be dominated by a small increase in the price, because the price is such a small fraction that if you have a fraction of the price changes, it's an even smaller fraction of your income. So you're not going to be very sensitive to it. So typically when the price of good is small to relative to the income, then you have an inelastic good. So the previous one was elastic. So I can maybe circle that. The previous one was elastic. And this one is inelastic. All right, so we'll go a little more quickly through this. What about if the good is a necessity? So this is a good you need. So if this good is something like rice, for example, this is something that you absolutely, or electricity, you absolutely positively need, and they increase the price on it. What are you going to do? Do you think this is going to be an inelastic or elastic good? So if I clear list right here, let's see the votes. Inelastic or elastic? Seeing so far, looks like more inelastics. Now some elastics. Now we're getting a tie. This is exciting. It keeps being tied, inelastic versus elastic. This is the harder one, huh? If a good is a necessity. Right now, it's sort of shifting a little bit. Looks like we're getting a little bit of an edge on the inelastic. I wasn't expecting as much of a tie here, so this is cool. This is interesting to me. The way I interpret this is that this is inelastic because regardless of what they charge, I have to buy it. If I have to buy it, I'm just going to pay them what what it is. So like for rice, we talk about rice being a Giffen good. If I have to buy a certain amount of rice, it doesn't matter what rice's price is, I'm going to buy it. What's going to happen though is I'll have less money available for other things. But I won't change how much I pay for this. I have to buy, water, like it's difficult for me to conserve water beyond, like if I don't have a yard, for example, if so all the water goes into just drinking water or something like that, I might say, well, I'm going to have one less glass of water per day, but maybe there's a lot of health reasons why I need the particular amount of water that I drink. So if it's a necessity, it's usually inelastic. It tends to be less responsive to price. Okay, so I'm going to circle inelastic for necessity. All right, and then habit forming. Here's another one. So, just with habit forming, and just to sort of speed things along here, this is one that I'll just go out and say that traditionally things that are habit forming are inelastic. And that's because it's like, let's say it's smoking, for example, or other things that you tend to do just because you have a habit of doing them, like getting coffee every day at noon from the coffee shop that's 3 floors down. If you just have a habit of doing that, it doesn't quite matter how much the coffee costs because you just do it. It's a habit. And so things that are habit forming, we also view as being inelastic. Similarly, if things are trendy or in fashion, so you say that well, I really like Apple devices. And so when Apple brings out a new Apple Watch, like they did, I don't know, an hour and a half ago or something like that, or whatever, 3 hours ago. So Apple brought out the Apple, whatever, Series 6 watch. And it's not really any different than the Series 5 watch, right? There's a couple of little things. But if you're really into having the latest device, if you're really into having an Apple Watch, if you're really into Apple products, it's not going to matter what it costs. You're going to spend it and assume that you'll be able to afford it. So you're not even paying attention to the price because you're more paying attention to the brand, for example. And so that's another one that I would typically view as inelastic. And you can think about that is because you pay attention to the brand, there's like no substitutes available. If there's no substitutes available, it's almost like it's a necessity. And so the more substitutes that are available, the more elastic it gets. The less substitutes available, the more inelastic it gets. All right, so there are questions about that, about the price elasticity of demand, how we go from thinking about price and thinking about what sign the demand is going to be. We'll talk about how to calculate it here in a second, but I want to make sure we're at least on board with our mental model of the way these things work. Okay. All right, now I mentioned there are other types of demand. You can also have an income elasticity of demand instead of the price elasticity of demand. And you ask the same sorts of questions. You'd say, if your income changes by a certain fraction, then how does the quantity of a good change? So for an inferior good, we know that if your income goes up, the quantity goes down. So we would have a negative income elasticity of demand. For a normal good, if your income goes up, the quantity you buy goes up. And so then we would have a positive for a normal good. So again, just trying to get you used to thinking about how does the quantity demanded change when the thing that's in front here, price elasticity of demand, income elasticity of demand, et cetera, changes. All right. Thanks for the feedback. So this is normally where you'll go and then answer questions 1 and 2 on the Canvas exercise. So after class, go ahead and answer questions 1 and 2, and that's part of the attendance for this today. All right, so let's start getting a little more numerical. Those were just kind of warm-ups here. First kind of question here, demand or inverse demand. We have to get used to just the names of these things because we have to call them something. So this here is a function that starts with price and then it gives you quantity out. So for any price that I give you, then it will tell me if I take that price, I multiply it by 1/2 and I subtract that from 50, then I get out of that a quantity which represents how much you're willing to buy like up to that quantity you're willing to buy for that price. And this mapping, when you go from price, when it maps to quantity, you go from P to Q, then that is something that we refer to as demand. It's the mapping of price to quantity. So when price is in the right-hand side of the equation and the left-hand side has quantity, then that is demand. And so we can ask questions about the mathematical form of this. And we can say, you know, one of the questions would be, well, all right, so if the product was free, so if they charged nothing for it, then how much would you be willing to buy? So if it was totally free, how much would you be willing to buy? And so I can plug in 0 here. So I can do 0 for this thing, and that kills this part. And it says that I'm willing to buy 50. And so the question here is then, well, you know, why not? Why not more? It's free. And this is where the stuff you're reading in chapter 2 about marginal benefits and marginal costs, I hope, starts to connect. Because what we're saying is that once you have 50 green balls, the 51st green ball is worth nothing to you. Once I have 50 green balls, that's all of the green balls that I ever needed. And you could give me 51, that's fine, but all I really ever wanted was 50. And if I get take the 51st, it's not worth any extra to me. Give me 55. I don't care about those extra 5 balls. I only really care about the first 50. And so the reason why free things aren't bought in infinite amounts is that diminishing returns, they fall off. The returns you get for every next one falls off. And so so that's what this price, when price is equal to 0, you can think of price as a surrogate for willingness to pay or value of the next item. When I own 50, the value of the next item is the price that corresponds to that. And that, in this case, would be 0. And so I'm not willing to pay for another one. That's one way to interpret this. Now, it would be nice if I could, ask the kind of reverse question. So right now I'm putting in a price and I'm asking how much am I willing to buy at that price. It would be nice if I were to ask the other way, where I would say, let's say you own 30. How much are you willing to buy, or how much are you willing to pay for the 31st? And that's what we get in the inverse demand function. So the inverse demand function is a function where instead of going from price to quantity, you take quantity as an input and you get your willingness to bet, your basically price, how much you're willing to pay for the next unit. And we can take the demand function, which is what I've got at the bottom of this slide, and turn it into the inverse demand function with some math that you might remember from, I don't know, high school, perhaps. And that is something where you basically take the demand function, which is over here. This is our demand function. And what I did here is I basically swapped where the function and the variable lived. And so this used to be Q of P, and I just turned it into a Q variable. And this used to just be P, and I turned it into a P of Q function. And now I just need to solve for P of Q, and that will give me my inverse demand function. So I take this demand function, and I'm going to subtract 50 from both sides. And that leaves me with this expression over here. And then I can swap them on the 2 different sides. So I'll put the Q minus 50, or basically I can multiply both sides by -1. So this Q minus 50 turns into a 50 minus Q, and this negative 0.5 turns into a 0.5. That's another way to view it. And then I can solve for my P of Q by dividing everything by 0.5. And by dividing 50 by 0.5 and Q by 0.5, I get this thing down here. And that is my inverse demand function, which again maps a quantity to my willingness to pay for the next item, given that I own that quantity already. So that is the inverse demand function. And it's just, you just flip the demand function to get that. And so if I'm given an inverse demand function, then I can more easily answer questions like, what is the choke price? So if I ask you on a homework, calculate the choke price, then what you're going to look for is, did I give you an inverse demand function? If I didn't give you an inverse demand function, you're going to want to create an inverse demand function from the demand function. And then once you've got that, the choke price can be found by just plugging in 0 for Q. So if I plug in Q is equal to 0 here, then that's going to kill this part here. And my choke price will just be the intercept, which will be over here. So that's my choke price right there. So if I give you an inverse demand function, the intercept of that inverse demand function is the choke price. If you don't remember what I mean by intercept, just plug in Q equal to 0 and evaluate. And when you plug in Q is equal to 0, whatever you're left with is the choke price. And so how both of these things relate to the demand curve is that, so I've got my, this one's going from Q to P. So up here, this first one is my inverse demand, and this one down here is going from P to Q, and that is my demand. And if I plot either one of those, they give me the exact same line, and that is the demand curve that I see plotted over here. So the quantity is on this axis, and the price, so I could call this P, is on this axis. And this blue line, all points along that blue line, you can calculate from either one of these two functions. These two functions just written with a different thing on the right-hand side of the expression. And so the choke price, which shows up as the intercept of the inverse demand function, is just where the demand curve intersects this price axis. There's my choke price. There's the 100 right there. And so that is effectively where P of 0, where the inverse demand function evaluated at Q equals 0 is equal to 100. And so what we're saying here is that the quantity that, so you can think of this, so this is Q is equal to 0. You can think of, I plugged in Q equal to 0, and as a consequence of plugging in Q equal to 0, then I got a P equal to 100 out. And so it should also be the case that if I plugged in a P equal to 100 into my demand function, I should get a Q equal to 0 out. And certainly if I go over to this, if I were to plug in a P equal to 100 there, then this would give me 0 out. And so they're just two sides of the same coin, the inverse demand and the demand function. Sometimes I give you price and you want quantity out, and so you use demand. Sometimes I give you quantity and you want price out, so we use inverse demand. So you need to be able to easily convert from one to the other. All right. Are there questions about that so far? About how we do the inverse, about how these three things relate to the demand curve and these two functions? And you're going to be doing several of those numerical examples on your homework, where I will give you one of these. I might give you the curve, and you'll have to, find the inverse demand function. I might give you the demand function to find the inverse demand. I might give you the inverse demand. You might have to find the curve. You might have to find the choke price. Okay. Well, if there are questions as we move forward, just holler. All right, so then we can ask other questions, like at what quantity demanded is the marginal benefit of another unit equal to 0? That's the fancy way of saying, how many green balls do you have to own for the next green ball to be worthless, for you not to want another green ball? How many green balls are enough? And we can answer that by looking at this curve. We can say, well, if I own this many green balls, then the benefit of buying another green ball, the marginal benefit is this distance right here. So it's not 100. My first green ball was worth 100 to me. My second green ball, not quite so much. So once I own this many green balls, the next green ball is worth a little less. I'm willing to pay less for it. And as I keep moving on here, as I own more of these green balls, then the value of the next one gets even less. And there's a question. For the question in the module, should we round to the nearest cent for the choke price? I don't remember the exact question. I would be surprised if I gave you something that didn't come out as a nice round number. I wouldn't put it by me, but I just would have expected me to put something that comes out as a nice round number. If it doesn't come out as a nice number for the question of the module, then yes, you can round to the nearest penny. Or if I've asked you for a numerical thing in the canvas, then I will have provided tolerances on that. So that's my kind of short answer without looking at the canvas to double check. All right, so this curve is telling me how much, as I own, how my value of the next one gets less and less. And so if I see that, then I can see that once I own 50 green balls, I am not willing to pay any more. So the next green ball, I will only accept it if it's free. So I don't really need them anymore. If you, I will take on 100 more green balls, but only if you give them to me for free. So that is how I can answer this question and how I can use the demand curve or either of these functions to solve that. Okay. So are there questions about that? The demand curve. And at this point in the online one, there's a couple of questions where I ask you questions about demand functions and demand curves and calculating these things. All right. Again, so we're going to keep moving on with stuff that looks very similar to the previous stuff. So you keep getting practice as we move on down through this, but feel free to holler again if something's not making sense. All right, so the other questions that we ask is something called consumer surplus, which has to do with if you take the benefit I get for the green ball, I also then have to subtract the opportunity cost from spending money on buying those green balls. So I don't actually get all $100 worth of benefit out of my green ball that cost $100. I only get the amount of benefit over and above the price that I was asked to pay for it. So if I had to pay $50 and I get $100 worth of benefit, I was willing to pay you $100, but you sold it to me for $50. Well, I buy it because I get $50 of benefit out of that green ball. So that's what we're kind of showing here, is that every green ball provides me kind of a gross benefit. And so this is like the first green ball, the second green ball, third green ball, and so on. And so, but in order for me to stock up on these, I had to pay the market price. And if the market price was fixed down here, then that means that for every green ball, this stuff down here was actually benefit I lost by buying the green balls. I had to give away that amount of money in order to, so you can think about it, this is the quantity and this is the price of those balls. And so the area of that rectangle is how much money I spent on my supply of green balls. And so the actual benefit that I take home at the end of the day is this triangle that's up here. And that's the so-called consumer surplus, as they are the sum of the marginal net benefits for every unit that I buy. And so I can figure out that if there's a quantity 30 that that I own, then I'm willing to buy. If I own 30, then I am willing to buy the next green ball at this price. So that's what kind of this demand curve is. And if I plug in 30 into this expression over here, then it tells me that if I own 30, I'm willing to pay 40 for kind of like the next ball. So that tells me that if someone out there set the price of green balls at 40, then what I would do is I would stock up on green balls up until I had so many balls that the next ball would only be worth 40, in which case I would get no net benefit from that ball. And so if you fix the price here at a price equal to 40, then that means that I'm only going to buy balls up to 30. And the take home that I'm going to get is going to be this triangle up here. And so this is in dollars. This is how much I'm going to spend on those 30. And the triangle above it is how much benefit I'm going to feel from that. And that's the so-called consumer surplus. And so the blue triangle that you see here is the consumer surplus for this good with this demand curve when you have a price of 40. So I might ask you that, what's the consumer surplus at a price of 40? And what you're going to do is you're going to have to figure out what this intersection point is. And once you figure that out, then you will know the length of this leg of the triangle. And then you'll have to calculate the length, oh, that was terrible, the length of this leg of the triangle, which is going to be 100 minus 40. So that's 100 minus 40 is the length of that leg of the triangle. It's not 40, it's not 100, it's 100 minus 40 to get the length of that leg. And then 1/2 base times height, that's how you get the area of this triangle. And that's going to just be 1/2 times 30, which is this distance here. And then the height is 100 minus 40, which is 60. So the consumer surplus is 1/2 times 30 times 60, which is 900. And that's the area of that. And if you need a unit for that, that's $900. So effectively, I have benefited $900 worth by buying these green balls. How have I benefited? I've benefited because I get more joy out of these green balls than the market is charging for them. And that's how I extract benefit from the market, is I buy things at a price that is less than what I'm willing to pay for them. And then the surplus, the consumer surplus, is the joy that I feel from them. Okay. So I can ask you, other questions. What is a consumer surplus for a per unit price of 70? So, we can do the same game here where I need that I know this distance, it's going to be equal to 30, 100 minus 70, but I need to figure out this distance, this horizontal distance. So to do that, I was given a price. So this is a price P. And so I then need to solve for the corresponding Q down here. And I know to go from P to Q, that's a demand function. So that's this thing. That's to go from P to Q, that's this thing down here. And so I plug in my price, I get my quantity out, and that tells me that it is a Q of 15. So that is this direction here is 15. And so now I know I've got 30 here and 15 here. So if I do 30 times 15 times 1/2, that will give me my consumer surplus here. And that's what I did there. All right, so questions about consumer surplus? Is it clear? Just exercises in using our inverse demand, our demand, and the demand curve to visualize it all. And if our demand curve was not a straight line, so if it was if this demand curve was slightly convex or concave, would probably be convex in our cases, then we would approximate these things with triangles. Or we might have to do a little calculus, but I'm not going to ask you to do the integration, kind of fancier calculus in this class. And so I will ask you to approximate it with triangles. So if I do have a demand curve which is slightly bowed, then you can approximate it by putting a triangle in here and guessing that consumer surplus instead. But in most cases, when I ask you to do a consumer surplus, I will give you a straight line to make the math easy. But I will give you more exotic looking demand curves when I ask you to sort of highlight something graphically where you don't have to actually plug in numbers. Any other questions about consumer surplus? It's pretty clear. All right. So at this point in the Canvas exercise, I'm going to ask you to calculate a few consumer surpluses, and it'll tell you whether you got the right answers or not. All right. So now we're kind of closing this thing out. We know about inverse demand, we know about demand, we know demand curves, we know about consumer surplus, but that's all so far been for an individual. It's my own preferences for these green balls. But I would like to know, how does the market feel about these green balls? And so I can add up my demand curve with your demand curve to come up with a market or an aggregate or a total demand curve. And that is what we're sort of representing down here. How do we do this? So in the chapter from Burke and Helfand, they talk about horizontal addition. And that's effectively what we're doing right now, the process that economists call horizontal addition, which might make sense if you think about it, but you don't have to worry too much. If you want more practice with this demand stuff, as a side exercise, you could pick either one of these demand curves, and you can verify that if you plug in a Q, you'll get a P out. And then if you plug in that P to the other one, then you'll end up getting the same Q back out. And so that can help you verify that these functions are really just inverses of each other, that they're just two representations of the same curve. Right now, when we combine these two, what you need to focus on is that every individual may have a different choke price, or different groups of individuals will have different choke prices. This type of individual up here is only willing to enter the market when the good is $100 or less per unit. Now, this other person or this other group of people, their choke price is different. They are not willing to buy the good at $90, even though this one up here is. They wait for the good to come down in price to 75 or less. And so if we think about market demand, then what we're going to see is as the price changes, you get new groups of consumers coming into the market, because some consumers were just waiting on a sufficiently low price in order for them to start consuming. And so that's what we have to deal with when we combine these things together. And so what we ultimately will get in our market demand curve, or total demand curve, or in this case, we're mapping P to Q, so demand curve, is this kind of what we call piecewise functions. And so this function, you plug a price in here, but then you have to ask, before knowing which part of the function to evaluate, you have to ask what range the price is in. If it's a high price, anywhere between 75 and 100, anywhere between the two choke prices, then we know that we only evaluate the first demand curve for the first group who's willing to pay more. If it's a low price, anywhere between 0 and 75, then we know that we need to add the demand curve that corresponds to the one who's willing to pay more, and the demand curve of the ones who are not willing to pay more, because they've now entered the market at these lower prices. And so that's what we need to build, is this market demand curve from these two pieces. And so that's all that we're going to do, is we're just going to take the expressions that are up here and we're going to plug them in down here in exactly that same way. So when prices are when prices are over 75 but under 100, we just use the higher priced demand curve, the one that corresponds to the individual who's willing to pay the higher price. In this one where now it's cheap enough that both groups of people are willing to participate, then we have to add both together. So we have the same demand curve from the first person, but we then can add in the demand curve from the second person. And we can simplify that. So you can see that we can add 50 to 150, and we'll get a 200. And we can add the minus 0.5 to the minus 2, and we'll get a minus 2.5. And that's what, when I combine those two, that's exactly what I get. So this here is a mathematical expression for the market demand curve. And we'll see what it looks like here in the next slide. But before I move on to that, are there questions about that, exactly how we got this expression? I gave you two demand curves and you added them together in this so-called piecewise demand curve. It takes one shape at certain prices and another shape at other prices. Any questions? Okay. So now that I've got the demand curve for the market, I need to figure out how the heck am I going to get the inverse demand function for the market now that I've got this weird piecewise thing. So I know that since I have a piecewise demand curve, I need a piecewise inverse demand curve too. So just like the demand curve has certain ranges of prices get mapped to certain curves and other ranges of prices get mapped to other curves. Then in my inverse demand function, certain ranges of quantities will map to some price curves and other ranges of quantities will map to other price curves. So if I look at this, I see that, well, you know, from 0 to 75 in the per unit price, if I plug in a 0 into this expression here, then I get 200 out. And if I plug in a 75 into this expression here, I get 12 and a half out. So that tells me that the top slice of the demand curve, which corresponds to prices from 0 to 75, is going to correspond down here to this bottom slice of the inverse demand curve, which corresponds to quantities from 12 and a half to 200. So I did that just by plugging in 75 into here and 0 into here. And those two together, if I take those two plugins, then that gives me those two numbers down here. And then likewise, for the other two ranges, if I plug in this 100 into here, then I get a 0. So that maps to the 0. If I plug 75 in to this expression over here, then I get a 12.5 out. So that tells me that this yellow group here of prices from 75 to 100 corresponds to this yellow group here of quantities from 0 to 12 and a half. So now that I know those ranges, then I just do my inverses for each range. So I basically say, okay, I'm going to pretend like this is the world, 50 minus 0.5p. I'm going to set that thing equal to Q and then solve for P, and then that's going to give me the expression I put here. And then likewise, for the range in the bottom, I take the corresponding expression for that range up here, I invert it, and then that's going to tell me what goes down here in this one. And that's what I'm just going to do here in this next group. Is I take this one, I set that thing equal to Q, and then I solve for P. And the expression that I get for P, which now has a Q in it, ends up being the expression I plug in here because those two ranges correspond. Same thing with the bottom half, is that I've taken the expression that went along with these prices, I inverted that expression, and then the result ended up being the expression that went along with these quantities. And that's how I get both my demand and my inverse demand for the market curve. And now that I have that, I can actually start plotting. And so before I get to the plotting, I just want to make sure, are there questions about that? What I just did there is kind of a little complicated. So it's reasonable that there might be some questions on how the heck did we get from these two lines up here to these two lines down here. Does anyone have questions that they might like to give? Or does this seem like it's coming out clearish? Okay. And again, these are things you'll see on the homework as well. And then as a reminder, the homework set for last year and its solutions are posted on Canvas. And so you can see me doing examples of this, more examples of this in that homework set. And then two other homework sets from another faculty member in sustainability, and their solutions are also posted there. And I believe he also did some of this horizontal addition stuff. So you can see some more examples there. All right, so now I'd like to see what the heck this thing looks like. So if I just focus on this group where my prices are going from 0 to 75, So and then price is this axis. And my quantities are going from 12.5 to 200. Then I basically get a line. So if I look down here, let's just look down at this line. These are, again, these are inverses of each other. So I may as well use the inverse demand function down here. And that shows me 80 is my intercept. So I plotted an 80 over here. And if I look at the other one, it shows me 200 is my intercept on the other axis. And so I can put that here. And I would normally connect a straight line there if that was the end of the demand curve. So I'm just putting a dotted line there to say sort of like, well, if all I worried about was that first group of people, so with, you know, or that if all I worried about was that the entire market acted this way, then I would just draw that demand curve. But in reality, I also have to worry about this other range. And in this other range, so these other sets of expressions, then my y-axis intercept is described down here as 100. And my x-axis intercept is described down here by 50. And so I combine those two lines and I get this dotted line, which is kind of like the demand curve if I only had to worry about the bottom piece here, if I only had to worry about this one. So by plotting those two together, I get a hint at what the actual demand curve looks like. And it is kind of like the combination of those two, where above this price, above 75, then I follow this steep demand curve, which represents only that one consumer participating. But then below this price of 75, both consumers participate. And now I follow the more shallow demand curve. And those curves are represented mathematically exactly as everything that's down here. And so that gives me that plot of those demand curves. So that's what an aggregate demand curve looks like, and how we can start with a model of preferences at the individual level that's linear. But once you look at the market, you can get these really weird shaped demand curves that are not linear and maybe are much smoother looking, because different people have different choke prices. And so as you sweep the price down, you get more and more people piling into the market. And so you're going to get a greater and greater quantity for lower prices. And that's what makes things kind of slope down, even if individuals don't slope down. So there are questions about that one, about drawing demand curves, market demand curves. Okay. All right, so I think there's only one other thing that I'm covering. Oh, there's two. There's PED is the last one here. So at this point in the Canvas exercises, I would ask you to do a problem related to building a demand curve in the market. Okay. All right, so now the really new stuff is this PED stuff. And so we got about 10 minutes left in class. So I want to make sure we get into this. So now I've got a market demand curve, and I want to calculate the price elasticity of demand at a particular price. And so this is a price of 50. 50 is down here, somewhere down here, and so it corresponds to some point over here, let's just say. And so I need to figure out how to calculate the elasticity of this thing. Now, here is my generic formula for price elasticity of demand. It is the slope of the Q to P, or of the P to Q function. So that's the slope of the demand function times the ratio of the price to the quantity at that price. And so all I need to do then is say, okay, for a price of 50, so I'm going to look here, my Q to P function. I say, all right, for a price of 50, that's in this upper range here. And so I can figure out, by plugging in 50 to this expression, I can figure out the corresponding quantity. So if I do that, I can see that 50 goes in, and this quantity here comes out of that. And so I'm going to look at that expression, and I find out that it's 75. So I know that my P to Q ratio, so P is going to be equal to 50 and my Q is going to be equal to 75. And so that is part of the PED expression. And so if I were to put parentheses around that, then that is going to represent this P over Q ratio in the PED formula. But I still got the other part to worry about. So then I have to figure out, okay, well then what is the, you can think of this, if you want to think in terms of calculus, what is the partial derivative of the Q function with respect to P? And if I look down here, if you take the derivative of this thing with respect to P, then if you remember your derivatives, then I just get a negative 2.5 out. That's one way to view it. The other way to view it, perhaps a simpler way to view it, is if I took a tangent line to the demand curve, which because the demand curve is linear, then it's easy. It's just the demand curve at that point. If I take the tangent line in that demand curve, and I take the slope of that, that tangent line, I say basically what is the slope in units or in terms of delta Q over delta P. And if I look at the slope of this thing, it's kind of the run over rise of this thing, then I can see that as I increase my price by 2 units or something like that, and so if I were able to kind of do the math here, so let's say I said, all right, I do a decrease in quantity of 75. So that's if I jump down from 75 to 0, then that is going to result, if I decrease in price of 75, then that will result in an increase in quantity of 200 minus 12.5. And if I do 200 minus 12.5, I get 187.5. So that's 187.5. And if I divide that by 75, then if I did my math right, 187.5 divided by 75 is 2.5. And then we have to just remember that conventionally, because the price decreased, but the quantity increased, then we actually say this is a negative. And so, so then we put a negative 2.5 in front here, and that ends up being our PED, the product of minus 2.5 and whatever this ratio is, 50 over 75. And so that's just what unfortunately is now under the marker, but if you were to do that, then it would be negative 1.67. And if I take the absolute value of that, as economists typically do, because we assume that things follow the law of demand, then we just get a 1.67. And so that's what is written underneath there as a 1.67. That's the absolute value of this thing. So if I put absolute value bars around this thing, that equals 1.67. So that's the PED at a price of 50. Okay. So because it's greater than 1, we say this is an elastic. It is elastic at this level. So we are at a price range where this is an elastic good. We can shift the price, and it might stop being elastic. But at least at this price, for a price of 50, it has a price elasticity of demand of 1.67. So if you were to change the price a little bit, you would see a large change in the quantity. And that in part has to do with you have lots of consumers keeping an eye on the price right now. Up in this region up here, the PED might be different. It might be a lot lower, and that's because you have fewer consumers buying. So changes in price don't result in as many changes in quantity. So that's kind of what we end up doing here. And because we don't have a lot of time, then I'll just sort of say, if we were to step through this question of quantity, then we can go backwards and say, well, if I start with a quantity of 5, I can solve for what corresponding price that is. And if I go through the steps here, then I end up doing the exact same calculation, and I end up getting a PED of 9. So for this particular good, then it actually turns out that it gets even more elastic at this price here. And so what we're saying here is that so many consumers dropped out of the market, and this particular consumer is so sensitive to price that now you have actually an increased sensitivity to price. So we don't quite know exactly how elasticity is going to work until we do the calculations. But once we get the calculation, then we know that for this price, so a price of 90, then we have it's very elastic. If you decrease the price a little bit, you'll get a lot more purchases. All right. All right, so we are at 103. Oh, okay, that's right. I'm sorry. I was looking at my timer and not at the time. And so I thought we were at 113 right now, but I started the presentation a little earlier. So I didn't mean to rush through that last one there, so I'm happy to go through that more slowly. Are there questions about those two examples of how you calculate PED for a complex curve like this one, given either price or quantity? And you just have to remember that you're looking for the slope of a tangent line at a point, and you're looking for that point. So I'm going to give you one of these, Q or P. You have to calculate the other one. And then once you know both, then you go to the curve, you draw a tangent line, and you figure out the slope of that tangent line. And if you're clever or more comfortable with the math, you can actually take this partial derivative applied to the right function down here, and you get the same thing out. But it's okay just to do the slope of the tangent line. That's fine too.
I got a quick question. Which slope of the tangent line did you use when the quantity was 5?
When the quantity is 5, great question. So, so here we're at this point, and so I would draw a tangent to the demand curve, which for this demand curve lays right on top of it. And then I calculate a slope of that tangent, which if I, so now I look say, well, how do I figure out the slope of that thing? Well, if I look at it, I can say, well, the delta, I'm going to pick a convenient delta P, and that is the jump from 100 to 75. Because I can tell that when I jump down from 100 to 75, I jump up from 0 to 12.5. So my delta P is going to be 25 because I jumped from 100 to 75. Okay. And my delta Q then is going to be, and I'll put a little negative sign just to be formal, is going from 0 to 12.5. So it's just 12.5. And it's just a negative because the price and the quantity went in the opposite directions. And so if I've done that right, then 12.5 divided by 25 is of course 0.5, and there's the negative sign there. So this right here is how I got the negative 0.5 down here.
All right, got it. Thank you.
Any other questions? Okay, great. So at this point in Canvas, you'll do a little price elasticity of demand calculation, and you'll calculate that, get a chance to practice that. Again, these are pretty low stakes, and I think you can take these attendance questions as many times as you like, and so it gives you additional practice. All right, so the last thing that I want to go over here is this kind of word problem that relates to this unit, but brings us back a little bit to thinking about our indifference curves. And so now we're not looking at demand curve, we're looking at effectively a point on a demand curve. And so I might give you a word problem like this one. And that word problem is that an indifference curve for two goods that have diminishing marginal utility is shown here. That's this curvy black indifference curve. This particular indifference curve is tangent to a budget constraint line, which is this thing here. So you could calculate this budget constraint line if I gave you the two prices at this point. And I then give you the prices. I say the price of good A is $10 per unit, and the price of good B is $5 per unit. And so so then my question for you is, if you look at this image, what is the marginal rate of substitution at the utility maximizing bundle? And so what you should be thinking when you look at this is that because there's diminishing marginal returns, this is the utility maximizing bundle. So really what I'm asking is, what is the marginal rate of substitution there at this point? And then I have to remember also at the equimarginal principle that the marginal rate of substitution is going to be equal to the ratio of the two prices. So really all I need to solve for is the ratio of the two prices, and that gives me the marginal rate of substitution at this utility maximizing bundle. So here's the formula for my budget constraint line. And so this is how we've learned to draw budget constraint lines, but you can also play with the math a little bit, and you can turn them into a kind of a y equals mx plus b form, where the vertical axis is B and the horizontal axis is A. And that kind of reveals that the slope here is equal to 2. And so that tells me that the slope of this line is equal to -2. So that's another way to view that is that the slope of this line is equal to the ratio of the prices. So we know the equimarginal principle states that the marginal rate of substitution at this maximizing bundle is equal to the slope of the budget constraint line. And so that tells me that my marginal rate of substitution at this budget constraint line is also equal to 2. So that's just saying that if the market is willing to trade 2 units of B for 1 unit of A, then it is best for me to buy and sell A and B until I am also willing to trade 2 units of B for 1 unit of A. And that's what this marginal rate of substitution is representing. So that's all what I'm kind of saying in this word problem. And so then in the Canvas, I would then ask you a question about MRS. Oh, yeah, so Mokshta, the TA, who I've never actually introduced yet, actually wants to, so I'll bring something up in just a second here. So just want to give some announcements. So for one, there is the Unit C reading. Maybe you've already started, but start reading chapters 2 and 3, and there is an activity, reading activity that is due before the next lecture. The due date on Canvas says it's due the night before, but it's actually available until the lecture. And I just do that as to not confuse people about due dates and timings. And so, it's due before next lecture, but the due date is sort of encouraging you to do it the night before. And then the other announcement is, again, so the TA has been online here. She's visiting us from 12.5 hours away. So it's late there, but because of that, she has the opportunity to also hold interesting office hours and things. So I'm going to hand it off to her because she's got an announcement about a homework study session that she'd like to hold later this week. So Moshe, would you like to take over?
Yeah, thank you. So I was hoping that, considering the B5 homework is due, the one on demand curves and stuff, I was thinking this Friday I was hoping to hold some kind of a homework study session. So we could go over the previous solution sets that have been posted, or we could go over questions that you might possibly have in class about these sums and stuff. So in case Friday is convenient, please just drop me an email and let me know. I was thinking sometime Friday day, which will be middle of the night for me, but that's kind of okay. Or if some other time is more convenient, just let me know. So for starters, I was thinking of doing that, but in case there are other questions that you guys want to approach or look at, I do also have office hours. So yeah, I think that's basically it. And I'm Mokshta because I've not really formally introduced myself before. So yeah, I think that's that.
Great, thanks. So if you, Friday potential study session, if you have any thoughts on that, major conflicts, are really excited about it, please feel free to contact Moshta. If you click on the instructor and TA information on the home page of the Canvas page for this course, then you'll find her information, her email information, her name, as well as current office hour settings and so on. So you can get in contact through there. I've also put Corinne, our instructional assistant, for those of you who are popping into the physical classroom, her contact info is there as well. So if you ever leave something in class or something like that and want to see if she's seen it, then her info is there as well. All right, so with that, are there any other questions about any of these things? You guys feel like you're ready to start working on that homework? Actually, I already had some people submit the homework, which I was really impressed by already. So you know, kudos, but no rush. It's got plenty of time to do.
I had one question, but I just don't know if, like, I had already emailed you, and I guess I want to run the question by you so you can tell me if it's like a personal question or a question for everyone. But like specifically on question 9, I guess I was just wondering what I was looking for, because I've already read all of the chapter 2 reading, and like I even went through and did Command F to find anything like relating to the topic of that question or like what to search for. But I guess I'm just looking for clarification of what I'm supposed to look for, I
well,
guess.
let me pull up here question 9. And so I don't know if I don't know if I'm still sharing screen right now. I think I am. So I don't know if you can see this here, but so question 9 for, on the homework, so I see only, I don't know. So can you be more specific? Because like,
I'm talking about activity C1.
Oh, I'm sorry, activity C1. Oh, I would, all right, well then I don't recall, I wrote that activity a while ago, so I don't recall specifically what that is. So, but I guess if maybe since we're getting to the end of class here, if you can summarize the subject of it, I can maybe help everybody in saying where to look.
Okay, so it was based on that reading, and it's that one question that has like the only question with an image that says the figure below shows marginal benefits and marginal costs plotted on the same axis. How is the area between, that's bolded, the MB and the MC curves related to the given abatement level X? So the area you're asking for is the area that isn't shaded, the area opposite from the area shaded. But I guess everything I like looked up in the reading, I'm guessing you said area between to ask us to further analyze it, because everything in the reading that I saw at least talks about area under, not area between. So I guess I was just wondering the difference.
Yeah. So area between basically means the area under the marginal benefit curve minus the area under the marginal cost curve. So when I was asking you to say area between, what I'm asking you to interpret is what happens when you subtract the area under the marginal benefit curve, when you subtract the area under the marginal cost curve from that, what's left over with that? And so that's something that they did talk about in the book. They may not have used the word between, but if you look at them talking about the area underneath both curves, then they talk about the difference between those areas and what is sort of represented there.
Okay, perfect. Thank you.
And yeah, we're 1:16 right now, so we are out of regulation time. I'm happy to stick around for a couple more minutes if there's a couple of questions. Otherwise, I won't hold you. So are there any other questions from the few left over? Okay. All right. Well, in that case, I guess that's all we have. So we'll be, again, starting a new unit, back to the textbook reading where we get more into sustainability starting on Thursday. So let me know if you have any other questions about the homework.